Welcome to my video on simple events, independent and dependent probability. So recall that probability of an event, the probabilities are always between 0 and 1. So let's look at the bottom of your note sheet and we'll look at it on a number line. And remember, probabilities can be expressed as decimals, percents, or fractions. So 0 probability means it's impossible. That is not likely to occur. And then if we have a probability of 1, that is certain to occur. So we would call this 0%, and we would call this 100%. That's definitely going to happen. Okay. And then right in the middle, we would have 1/2 or 50%. So for our note purposes, the examples that we're going to look at, we're going to look at it on a number line. When you do your classwork and homework, you don't have to write the number line. I'm just showing you in your notes how to look at it on a number line, because oftentimes probabilities are compared on a number line. So let's look at a simple event. So simple event is finding the probability of one event occurring. The word or can also be used to represent one event. So an example, what is the probability of rolling a 1 or a 2 on a dot? The probability would be 2 out of 6, or 1/3, since there are 2 possible outcomes out of 6. This is still one roll of the die, or one event. And then, of course, we have pulling, another example here, pulling one sock out of a drawer and examining the probability of getting one color. Okay, so the formula for this is or the probability for this is our desired outcome divided by the total outcomes. So unfortunately, the way these notes play out, we have to go, we have to turn to the back in order to complete the example. So it says a bag contains 3 red marbles, 4 green marbles, and 2 black marbles. What is the probability of a red marble being pulled from the bag? Okay, so we want to know the probability of a red being pulled from the bag. So we just have one event here. So we have 3 red, and now we have to count these up. So we have 3 plus 4 plus 2, which is 9. So we are going to write probability as we have red, so that's 3, and we'll call T for total, so 3 out of 9. And we can draw our arrows here. And then we're going to simplify that. We always must simplify our fractions. So we're going to divide top and bottom by 3. And we get 1/3. Now I'm going to put this on a number line here. Now remember, when you do your classwork, unless it tells you to, or your homework, or a worksheet, unless it tells you to, you do not have to do this number line. But for our note purposes, let's go ahead and put it in there. So we have 0, 1, and 1/2. And 1/3 is about 33, or it's 0.3 repeating as a decimal, which is about 33 1/3%. So that would be right about here, because half would be 25%, halfway between 0 and 1/2. So be right about here, roughly. Okay, and that would be 33 1/3%. So not impossible, but not extremely likely to occur. Okay. All right, let's look at independent probability. So let's scroll back up to the top here. Well, I'm going to scroll back up to the top. You're going to go back to the first page of your notes here. And independent probability is when the outcome of one event has no effect on the outcome of another. So there are two events happening here. If two events are independent, meaning they don't depend on each other, then the probability of the second event does not change regardless of whether the first occurs. It will often say with replacement for independent probability. Okay. Here's another example here. The first roll of a number cube does not influence the second roll of the number cube. Another example might be I flip a penny and then I roll a die at the same time. Those don't have any effect on each other. Okay. So let's look at what the formula would be. So now we have two events. So what we have to do is we have to find the probability of event 1, which is your desired outcome over the total. And then we have to find the probability of event 2. And notice we're going to multiply them together. And remember, this is very similar to, this is basically the counting principle that you learned previously, where if you rolled a die and flipped a coin, how many outcomes would there be? You would do 6 times 2. Okay, so that's what's happening here with our probability. Now let's look at an example. A bag contains 3 red marbles, 4 green marbles, and 2 black marbles. What is the probability of a red marble being pulled from the bag, being replaced? Okay, this is very important here. It's being replaced and then pulling out a green marble. Okay, so let's bring this back into focus here. Here we go. So we want to replace this. So we're going to write the probability of a red marble first. So that's our event 1. So we're going to write 3 out of 9. Now, because we're replacing it, when we do our second event, there's still going to be 9 marbles in the bag. And now we're going to pull out a green marble. So we have to look back up here and we see 4 green. Now, we are going to simplify before you multiply. So what we always try to do is cross simplify if we can. And I notice when I cross simplify, I'm looking diagonally. So I look at 3 and 9. And I notice that I can divide both those numbers by 3. So 3 divided by 3 is 1. And 9 divided by 3 is 3. 1. Now I'm going to multiply my numerators and denominators. So 1 times 4 is 4, and 9 times 3 is 27. Now, if I don't cross simplify, am I still going to get the answer? Absolutely. I would get 12 over 81, but that would be more challenging to simplify. You could, but if we cross simplify, then we don't have to do any simplification here. Okay. Let's look at it on a number line. So once again, draw this in. We have 0, We have 1 and we have 1/2. And 4/27, let's see, would be about be 0.148, so be 14.8%, which would be pretty close to 15%, which would be right about here. So once again, not real likely to occur, but not impossible. All right, let's look at our last section here. We have dependent probability. So dependent probability is when the outcome of one event has an effect on the outcome of another. If events are dependent, then the second event is considered only if the first event has already occurred. It will often say without replacement for dependent probability. Okay, so an example, we're going to look at one down here, but one I just thought of is, let's say you had 10 pieces of bubble gum in a bag, and you reach one out and you eat the piece of gum. How many are left? Okay, 9. So when you do the probability of the second event, you would only have 9 pieces of gum left, okay, if you were choosing 2 pieces of bubble gum. Okay, here's another example. If you choose a blue card from a set of 9 different color cards that has a total of 4 blue cards, and you do not replace that blue card back in the set before selecting a second card, the chance of selecting a blue card the second time is diminished because there are now only 3 blue cards remaining in the set and a total of 8 cards. So the first probability, so it might say what's the probability of choosing a blue card and then another blue card. So the first time, if you had 9 cards, would be 4 out of 9. But since you're not replacing it, the next time would only be 3 out of 8. So you've got to make sure you are reading the cards or the problem carefully. So the formula would be event 1, which is your desired over your total, times event 2, which is also your desired over total. But remember, your second probability is going to depend on what happened in the first probability. So let's look at an example. A bag contains 3 red, 4 green, and 2 black, just like the previous problems. But listen to this. It says, what is the probability of a red being pulled from the bag without replacing it, and then pulling out a green marble? So let's look here. We've got a red, so we're going to do 3 out of 9. And then we are going to pull out a green. But remember, we're not replacing that red marble that we pulled out, so now there are 8 marbles left. And how many green would still be left if we pulled out a red? Well, there's still going to be 4 there, so it's 4 out of 8. Remember, simplify before you multiply, so we're going to look at cross-simplifying, and we cannot cross-simplify diagonally here. But I do notice I can simplify the fractions. So 3/9 I can divide top and bottom by 3, so that would give me 1/3. And 4/8 I could divide top and bottom by 4, and that would give me 1/2. Now multiply the numerators. 1 times 1 is 1, and 3 times 2 is 6. So the probability of picking a red and then a green would happen 1/6 of the time. So in other words, if I did this experiment 6 times, I would get a red first, then a green, 1 out of 6 times. Now let's look at it on the number line. I'm going to put it over here, but you can put yours right below. I just want you to see this all on one screen. So we got 0, 1, and 1/2 would be in the middle. So 1/6 is 0.16 repeating, which would be pretty close to 17%. So we're going to put it right about here. Not impossible, but not extremely likely. So that concludes my video on simple events, independent and dependent probability. Please let me know if you have any questions, and have a great day.